Okay, welcome back. This is now 6.5, and we're dealing with a general factoring strategy. So basically just putting together everything from 6.1 to 6.5 and attacking pretty much any trinomial sent your way. You should be able to factor it. Trinomial or binomial or even 4 terms. So our strategy is as follows, and you don't have to memorize the strategy. It's hopefully we expect that if you do enough of it, it's going to be kind of automatic. But first, of course, is to factor out the GCF. So you should always do a preliminary scan and make sure there's no common factors. And if there are common factors, you factor them out. It'll make your life a lot easier. You still forget every once in a while, so don't kill yourself over it or anything like that. Don't get carried away about it. After that, you're going to factor based on the number of terms present. So using the pound symbol here for number, factor based on the number of terms. Okay, so the first case, the 2-term cases, and what we had, a squared plus b squared. When you saw that, that was prime, so you couldn't factor that. Then there was the ones that weren't prime, of course, a squared minus b squared, and that would be a plus b times a minus b. Okay, and then the cubics, so we just saw these in the last section, of course, a cubed minus b cubed, using the SOAP formula. Same sign, opposite, always positive. And then we need a, b, a squared, a times b, and then b squared. And then we had the sum of cubes. So same terms, but with different signs. Same sign, opposite, always positive. So I have a, b, a squared, ab, and then b squared. And then 3-term polynomials, 3 terms. We had the sum of squares, or sorry, the, what were they called? Perfect square trinomials, sorry. And so they would look like this, a squared plus 2ab plus b squared, and then you would have a plus b times a plus b. Okay, and then the other kind, a squared minus 2ab plus b squared, those would result in a minus b times a minus b. And then otherwise, usually just trial and error. So depending on your given polynomial, you'll set up your parentheses, get the signs in their appropriate places, and then just guess. What times what is b squared, and then you need the outer and inner to add to the middle term. Okay. See if there's 4 or more. In those cases, you could do grouping. And later on, we may have some other methods for attacking those problems. After you do that, thirdly, you sort of want to, again, spot check it and see if you can factor it a little bit more. So see if you can keep factoring. And then fourthly, I would like you to check it by multiplying by FOILing back out, either in your head or in the margin. Okay, so in this section, you'll just be given a bunch of random now polynomials, and you'll be expected to kind of identify the type and factor them accordingly. Okay, so number one, we want to get that negative out of the lead position. We also want to get the GCFs out of there. Obviously, you could divide both by 7, and then you could divide both by an x. So what's left over, we'll have x minus 5. Okay, scan it, make sure you can't go any farther. Looks like this one's done. Okay, not much else you can do there. Number 4, we have 100 x squared minus 81. Okay, it doesn't seem that there's any GCFs. Nothing's going to divide both 81 and 100. So it has 2 terms and it's a minus, so I think it's a difference of squares. Okay, plus minus. What times what is 100x squared? Well, 10x. And then what times what is 81? Well, 9. And I can flow it back out and make sure it works. Let's just keep going. Um, 64x cubed minus 1. This is a difference of cubes. Okay? So you may want to set up your parentheses first. It's going to go plus, set up your parentheses first. It's same, opposite, always positive. Our A is 8x, our B, or sorry, 4x. 4 times 4 is 16, and then 16 times 4 is 64. And our B value is 1. And then we need to put A minus B, and then A squared is 16x squared. A times B is just 4x, and then B squared is just 1. Number 8, we have 7x plus 7y plus x squared plus xy. Okay, so this time we have 4 terms, and we'll want to do grouping on it. So I'm going to factor GCFs out of each pair of 2. So the first pair you can factor out 7. And then the second pair you can factor out, it looks like an x. And then at this point you can factor out the common term here of x plus y. It's a binomial, but that's what you're pulling out. Okay? And once you remove those, the leftover bit is just 7 plus x. Okay, let's look at 10. So we're just going to look at a whole bunch of them in this section. 3x squared plus 2x minus 5. Let's set up our parentheses. It's got to be plus minus. And then it's got to be 3x and x. And then 1 and 5 or 5 and 1. If you put 1 and 5, the outer terms are going to be 15, which is just way too big. So I'm predicting it's going to be 5 and 1. Okay? And then maybe we'll have to worry about the sign. Let's FOIL it out and see if it works. So first 3x squared, the outer, minus 3x, the inner, plus 5x, the last, minus 5. Looks like I got it. Okay. Let's look at 18. We got 4x cubed minus 100x. So this time I can factor out a GCF of 4x. So be left with x squared minus 25. And then you look at it and see if you can keep going. And yeah, this is a difference of squares, so I'm not done. I'm going to set up my parentheses, get my signs, plus minus. It's got to be x and x, and then 5 and 5. Okay. Let's look at 24. So this one's special. I'll probably be harassing you on a quiz over this one. Maybe not. But the deal is, it's like you think you're done, you're not done. You can keep going. All right, so first off, there's a common factor of 7, so we'll factor that out. Then these are actually a difference of squares. Okay, so you can keep going there. What times what is x to the 4th? Well, x squared times x squared. Signs have to be plus minus, and then 1 and 1. This is a sum of squares, so it's prime. You can't factor it. But this is a difference of squares. And that's my point. You can factor it again. Okay, so the x squared plus 1, is dead in the water. But then you can factor the x squared minus 1 again. So you'll have x plus 1, x minus 1, and that'll do it. So 26, you have x cubed plus 3x squared minus 25x minus 75. Right, so 4 terms, we hope it's grouping, and sure enough it looks like it. So for the first 2 terms, I think I could factor out an x squared, leaving me with x plus 3. The second 2 terms, you want to pull out a minus 25. And that'll leave you with x plus 3 again. And that's exactly what you want in these circumstances. You want that common binomial to factor out. So you'd be left with x squared. Oops, let's just factor out the x plus 3 first. So x plus 3 times the leftover part, x squared minus 25. And then you can keep going. So this is a difference of squares. We have x plus 3 times x plus 5 times x minus 5. Let's look at another one here. 28. So I have 5x cubed minus 20x squared plus 20x. Each term has a factor of 5 you can pull out, and then as well a factor of x. So the leftover bit's x squared minus 4x plus 4. And we're not done. Looks like it has to be minus minus. You have to have x and x. And I think this one's a perfect square trinomial, so 2 times 2. Let's FOIL it out to make sure. So I have x squared from the first, the outer minus 2x, the inner minus 2x, and the last plus 4. So minus 2x gives us that minus 4x, and it worked. One small point here is when you write up your answer, you can leave it like this, but you can also write it with exponents. So you can also write x minus 2 squared. X minus 2 squared is the same as x minus 2 times x minus 2. let's keep moving. So we get 56. Yeah, negative 7y cubed plus 21y squared minus 14y. Okay, I want to factor out that negative first off. Then each one is divisible by 7. And then I can factor out y as well. Okay. That leaves me with y squared minus 3y plus 2. And then you can factor this guy. So I got negative 7y times, looks like y and y. The signs have to be minus minus. And there's only one factorization of 2. It's 2 and 1. Some of these will end up being prime, and you kind of have to stop, but I think this one's good. Let's FOIL it out just to make sure. So I got y squared versus the outer minus y, the inner minus 2y, the last plus 1, or sorry, plus 2. And then just, spot check, make sure it's the same. Yeah, it worked. So we're good. What else? So we get 78. X to the 4th plus 27x. We'll just do 2 more with multivariables after this one. I could pull out an x. That's going to leave me with x cubed plus 27. This is a sum of cubes. So I can identify my a and b values. My a is x. My b is 3. 3 times 3 is 9. Times 3 is 27. And then I could, do your factorization. Same, opposite, always positive. And we have x3, x squared, 3x, and then 3 squared is 9. Every once in a while you can factor these guys, but it's pretty rare, so I never even bother. I won't even check it 99% of the time. Okay, let's just look at one more. This is 88. We got some multivariable deals going on here. 24a to the 4th b, as in beta, or boy, plus 60a cubed b squared, plus 150 a squared b cubed. Okay, first, pull out any GCFs, and obviously all 3 of these are divisible by 6. It may not be obvious, but if you play around with your calculator, you figure it out. The lowest exponent on the a's is 2, so each is divisible by a squared. And likewise, the lowest exponent on the b's is just 1, so I can pull out a b. That'll leave me with 4 a squared plus 10a times b, and then plus, how many times does 6 go on the 150? 25. 25 b squared. You always want to check to see if you're done or not, and I think we can factor this again. It looks like a perfect square trinomial, so let's go at it. The signs have to be plus and plus, and we're hoping for 2a and 5b if it's a perfect square trinomial. Okay, so let's just check it and see if it is. First, 2a times 2a is 4a squared, the outer plus 10a b plus the inner 10a b, and then plus the last 25 b squared. Okay, so no, it didn't work. I'm kind of bummed. Um, maybe I made a mistake. That's what I'm like thinking. Maybe I made a mistake. I don't know. It didn't work. Yeah, it just didn't work. I guess this must be prime then, is what I'm thinking. I mean, there's no other way around it. You can go 2 and 2, and then if you put 25 there, it's just going to be huge. So I'm thinking that has to be your factorization. You're done. Okay, well, there's that. Okay, see you next time.